Hello, hello. Are we live? Firefox is freezing up. Are we? Alright. Welcome back to the advent of syntran. Today is day 22. So let's make a new directory. Okay then. What is going on? Reverse incremental search is failing me. No push D either. Oh, there's push D. Nothing else was in my history. Let's take a look at the puzzle. I have looked at this ahead of time. So we have 3D Tetris, basically. You have a series of bricks. Every brick is rectangular, right rectangular prism. So these are the minimum x, y, and z coordinates of a brick, and these are the maximum x, y, and z coordinates of a brick. So the brick is between this corner and that corner. And then the next line is another brick. So they start out somewhere in space. Golly, I'm not supposed to be on my desk. So they start out somewhere in space, and then whichever brick is at the bottom will start falling, and then the bricks will eventually land on the ground. Is the ground at 0 or 1 or below 0? I think, well, first of all, Z is the up-down direction, so I think positive Z is up and negative Z is down. Callie, I can't really see anything. Where is the ground? Sounds like Callie's eating something, but there's no food in here, so it's pretty weird. The ground is at Z equals 0. Okay, so eventually the bricks hit the ground and then they stack up on top of each other. And even if a brick lands on another one like this, it doesn't rotate. It just stays in its original configuration. So we don't really have all of the laws of physics. It's like Tetris physics. If a piece hits a corner in Tetris, it just stays there. It doesn't like rotate down by itself. So we don't have to deal with any rotations. So that aspect of Tetris is absent from this puzzle. And what do we have to figure out? Oh, okay. I looked at this last night, but then I forgot about it. Callie can't be up here, I'm sorry. So after the bricks land on top of each other, we have to figure out, now it's like a game of Jenga. We have to figure out which bricks can be removed without causing any other bricks to drop further. So they say which bricks are safe to disintegrate. And the final answer that they want is just the number of bricks that can safely be disintegrated. The disintegration is happening one at a time. So like we're not disintegrating multiple bricks. We're just considering if one brick can be disintegrated without disturbing the rest of the stack. And then they want to know how many bricks are there like that that could be disintegrated. But we're not actually disintegrating more than one. So I think this seems doable. I've heard that the last few days are supposed to get easier. Like, I think a lot of people agree that day 17 was a pretty hard problem, and day 21 was a pretty hard problem. So allegedly these are supposed to get easy in the last few days, but I'm not really sure about that because I remember struggling still on day 23 last year. I can't remember the details of that, but I know I didn't get part 2. So let me save this input. And I should be able to echo that. And there's the test input. So now I have to parse that. Just thinking about what kind of data structure of arrays I want for this. And I think I want 6 different arrays for the minimum and maximum positions in the x, y, and z coordinates. So 7 bricks, that sounds about right. Let me actually open that up in a text editor. Yep, we've got 7 lines of brick data. When I can, I think it makes sense to read a line at the top of the loop. I frequently don't do that because I don't always count lines ahead of time, and then there's frequently something in the first line that I want to count to like know the size of like an x dimension of the problem or something like that. But we don't have that today. It's 3D and there are min and max coordinates, so we're always going to have 6 numbers per line and some delimiters. I'm going to use very short variable names. Just NB instead of NBrick. And then I'm going to have 6 different arrays for every coordinate. Do we ever have negative numbers? Not in this. Any negative numbers in the real input? No. So it shouldn't really matter. Well, actually it does. Because I think I want to have a voxel grid to keep track of where a brick is and where bricks aren't. So as long as there are no negative numbers, that makes that easier. So I want to parse some numbers out of a string, and there will be commas as a delimiter and also a tilde as a delimiter, right? Yeah, so we have a tilde between the min and the max. So I just want to consider that as a delimiter. and then this will give me a vector of 6 coordinates, and then I want to unpack those into these variables. I wanted to make this a for loop. This is 3, 4, 5, not 4, 5, 6. I think that should get the data that I want. This might not print very readably, but that's okay. Okay, yeah, so we just got every vector in one line. Oh, yeah, I almost forgot. Was that yesterday? I can't even remember which day it was that I was debugging split. But I don't want to print all of this stuff. And I shouldn't have even committed that, but I was tired or I was in a rush, so I committed that anyway. Okay, that's a little bit cleaner. So now we basically have the first column all in this vector, and then the second column is the y minimum, third column is z minimum, and then we have the max of every coordinate of every brick. So I think that's the way I want to work with these bricks. And I also want a voxel grid. Well, that might come later. So these, I think these start somewhere, but then they fall. Yeah, so the input is really the bricks while they are still falling. So these bricks are like mid-air. They're not necessarily in any sort of order. Actually, they are in order by min z coordinate. Is the real input like that? Because that would really make things easier. Then I wouldn't have to sort. No, yeah, so the real input is not like that. So here we have min z1, min z2, min z3, 4, 5, 6. There's no 7, but 8 is still sorted in the right order. So what this means is that this brick will start falling first, or we can simulate the falling of this brick first and let it hit the ground, and then anything else will potentially end up on top of that, because this one is lowest to begin with. The real input is not that convenient. They have z coordinates in seemingly random order. I think we can live with that. So what I have to do is sort these bricks by the minimum z coordinate, because whichever brick has the lowest minimum z coordinate is going to start falling first. Okay, so the ground is at 0, but the lowest z value a brick can have after it falls is 1. And how big is this space? So everything falls downward as far as they can go. So I want to know how big is the space. So what's the minimum z coordinate of all the z coordinates? And same question for x, y, and z. And then what's the maximum of all the maximum? Or all of the maxima. It's the plural. Wrong file. So what do I want to initialize these to? That's nearly the max 32-bit integer. So I want the minimum of all the minima. So that's going to be it's going to be a positive number initially, and then I'll take the minimum. And then I want the max of all the maxes. But these I should initialize to a negative number. And then every time I get these coordinates, I'm going to accumulate the min and the max global. I don't know if I like these variable names. There we go. Little fancy search and replace. I think that's right. Now I want to know what those are. That's not what I wanted to do. Okay, I want some delimiters in there. Hey, Vision for All. How did day 22 go for you? Did you do this one yet? This is, yeah, 3D Tetris. That's exactly what I said at the beginning of the stream. The good thing is there are no rotations, at least not for part one. Like last year we had a Tetris problem. I think there weren't any rotations in last year's Tetris problem either, but there was like shifting to the left and right. And today for part one at least, there's no shifting and there's no rotation. It's just everything falls straight down. So that makes things a little bit easier. Okay, so the min x is 0, the min y is also 0, and the min z is 1. Golly. There's no hash catting today. Okay, she jumped down by herself. And then the max of all the x's is 2, y is also 2, and then z is 9. So I think this is correct. And now I can allocate like a big voxel grid to just keep track of where things are and where things aren't. So this is going to be a Boolean array. Yeah, do I want a Boolean array or do I want an integer array? If I used integers, I could keep track of which brick is in each location. And that might sort of future-proof things, since I don't know what's coming in part 2. Yeah, I think I might do that. It shouldn't be much harder, and I'll have more data just in case I need it. So I can use like 0 to say there's a brick 0 is at a certain location, and 1 to say brick 1 is at a certain location, and then I can have negative numbers to say that a voxel space is empty. So we know that all of these numbers are positive, so I don't have to worry. That makes my job easier. I can just allocate it to the maximum size. In fact, I might not even need the minimum variables that I just set up. This is bigger than it needs to be because we have the ground at 0 and the lowest place that a block can be is 1. So this is a little bit of a waste of memory, but I think even the real data, the space is not that huge. But I do want to check this. Okay, so it's really not that big in X and Y. It's only 10 by 10 or 9 by 9. And then Z, it's only up to 300. So this is not huge. And I think the next thing is to to sort the bricks by the minimum Z location. So I'm going to use the quick sort routine that we used yesterday. Okay, Kelly, I'm sorry. You've got to go. I'm sorry. I'll use the quick sort routine that we used yesterday, but I actually want to get an index array out of it instead of like modifying things in place, because I don't want to have to modify all 6 of these arrays. I just want to sort it once by z min, and then get an index array out of that that I can use to map everything else. Maybe you have to sort the edges of the bricks. Yeah, like the minimum z edge. I think I did that some other day. I can't remember which day I used bubble sort, and I used an index array. I think I have to go back. Yeah, day 7 at a bubble sort. Oh, that was for camel cards, because we had to rank all of the cards, and then I did return an integer index array. So it's going to be like that, but I want the sorting efficiency of quick sort. So I think I can just adapt yesterday's quick sort. The min-max. Yeah, I have 6 different arrays for everything. Pretty sure that was yesterday. Everything is blurring together. And I can't remember which day or which problem was on which day. IX is going to be my index array. So initially it's just the identity mapping, and then if this array is already sorted, using this index array doesn't do anything. And now, everywhere that I have V, I want to give that a nested subscript. And I think I can come up with a regular expression to just replace everything magically. Something like this will be a little tricky. Well, no, so this is going to be a lot of code to modify. Maybe I should just use bubble sort. Okay, so I want to search for V. Anything, any number of times, but I want a capture group for that. So anything, any number of times, and then the closing bracket. I want to replace that with an index array. And then whatever was in the capture group. And then close a bracket, close another bracket. Why is that not closing all of the brackets? Do I need to escape these? That is not working. Well, it's pretty close to the right answer. Oh, it's greedily doing the whole line. Okay. So I want anything that's not a closing bracket. There we go. And then I shouldn't have to escape all of these. That's the regular expression I want. So anywhere that I have a v subscripted by an index m, this now replaces it with v subscripted by ix subscripted by that same index. That's what the \1 reference does. It takes anything that I had inside the parentheses here and it just drops that in at \1. So replace that one, replace that one. These are actually, I triggered series somehow. Okay, she's done. Actually, don't want to replace these because I want to swap indices. I don't want to swap pieces of V. I do want to replace that one and that one, not these. And then that's my pivot. Okay, I think that's as much as I wanted to replace. Now, whenever I'm swapping, I don't want to swap pieces of V, I want to swap the indices. And then X is my pivot. And that might be it. Does this work? Who knows? And then instead of returning V, because I haven't actually changed V inside of here, I want to return the index array. Okay, let's see what that does. Let's see if we can sort the minimum z coordinates. And for the test input, it's already sorted, so we should just get the identity array. It should be 0 through 6 or 0 through 7. Yep, so that's the index array that I wanted. I think I need to test this on the real input. And I don't need to print every line because there's a lot. So I have no idea if this is right. Now what I need to do is print the min z coordinates and index it with this index array to see if it comes out sorted. That's z min. That seems okay so far. Looks sorted. So we have all the ones at the beginning, and then 2, and this is just ascending. So I think that worked. I'm a little bit surprised I got that right on the first try. All right, and then we can sort by z min, and then we can change all of the other arrays for x, y, and z, min, and max. So now I think we can drop the bricks towards the ground, and figure out where they are after they fall. We're not ready to disintegrate yet. We first have to figure out where they end up after they fall. So we're going to loop through all the bricks. And I'm never really going to use this I index. I just need to get something out of my index array. So we're going to use I as the actual sorted index. It's going to be the sorted index at II. And now we play Tetris. We drop it until it either hits the ground or hits another brick. So this is initialized to -1. Okay, I can set this lower down. Doesn't really matter. So basically bricks are either falling or resting. And we're going to loop until the brick is resting. So while not resting, we're going to loop. And then the first way that a brick can come to rest is if it hits the ground. The other way that it can come to rest is by hitting another brick. But for the very first brick, we know there's going to be nothing below it because we're looping in order. So it's going to stop when it hits the ground. I'm gonna say less than or equal to 1 just to be safe. This should work if I just say equals 1. And if it's not resting yet, I would like to do this without having an if condition inside my while loop, which is checking the same condition. But I don't know if I can get around this easily. So if it's not resting, we're going to decrement the z min and the z max coordinates. X and y are going to stay the same because we're not translating left to right or back to front. We're only dropping downward. But we do need to change min and max. Because the brick doesn't stretch out as it falls. The top and the bottom of the brick both fall at the same rate. So this is the hitting the ground condition. Yeah, I have to have something copied in this loop. I either have to have the condition checked here before I decrement, or I have to initialize resting to this condition and the condition of hitting some other brick. And if I have to copy one thing, I'd rather just copy this. Okay, so all of my bricks hit the ground because that's the only condition I have in there right now. I want to go back to the test input. Okay. So the other condition is if one brick hits another brick, then it will also come to rest. I think I want to delete that other buffer. At the end of this loop, I have to enter the brick's position into the box array, because this is how I'm going to check for collisions. Maybe I want to do that first. Now you have to be careful with off by one errors, because some of these bricks, the way they give you the input, the bricks have like 0 width, but 0 width is actually 1 width. So what I mean is this brick has min z1 and max z1, but it actually takes up a whole voxel space. So we're going to have to go from the minimum to the maximum plus 1, because that's the way my my lower and upper bounds work in syntran. So that has to be +1, and it's the same thing for x and y. I want these to be indices, actually. So -1 will mean empty, and you could probably do this with a Boolean array, but I'm going to use integers because this is initialized to -1. So -1 means empty. Maybe that's more readable. Now, this is like a 3-dimensional loop. It's 3 nested for loops, so it's looping through each dimension individually. To check for collisions, you don't need to loop through Z. You only need to check the lowest slice of the brick, because as it's falling, it's going to collide at the bottom first. The bottom of the falling brick is going to collide with the top of another brick. So we don't need to iterate through Z when we're checking for collisions. So we're just going to do let Z equals Z min I. And then we still need to iterate through X and Y because it could collide at the left bottom corner or it could collide at the right bottom corner of the brick. So we have to iterate through all of those. Yeah. And I want these to be while loops because as soon as I detect a collision, I'm going to break the loop. And then we also have to check X. So here's the thing, the ground is at 0, but then the brick, if it settles on the ground and not another brick, it's at Z equals 1, not 0. So I actually want to check Z min -1. I basically want to check if the brick is going to collide on the next step after I increment this, or decrement. So I want to make that -1. And then, what did I just do? So resting is going to be vox x, y, z not equals empty. I think that's it. So if I did this right, we should end up with something that's not just all ones, because some bricks shouldn't be resting directly on the ground, they should be resting on other bricks. Okay, that seems reasonable. I don't know if it's totally right. So clearly these are the bricks while they're still falling, because there's nothing at 7. But after they come to rest, what does it look like? So we have A at 1. I guess we have B and C at 2. A, B, C, D. This is D. Oh, we have something at 3. I don't know. Okay, so they are lettered in order. I don't think this is right. Okay, B and C are 2. That part seems right. I want to do this at the end of the loop. So will this change my answer? Okay, that's good. That changed the answer. Because we had G at 3, basically, if you call these bricks A, B, C, D, E, F, G. Now G is at 7, and I think that's at least closer to what we should have gotten. 7. And I don't think 7 is right, though. What the hell is the question mark? Is that like 2 different bricks? Bricks are hidden behind other bricks. Wait a minute. Yeah, G should be minimum 5. Do I want -1 here? I don't think that's right. D and E should be at 3, not 4 and 5. A, B, and C are correct. But then D and E are not correct. Basically, D and E don't move. They start out at 4 and 5. I need to print this before and after. So A doesn't move. B doesn't move. C drops by 1 position. And I have C correct, that drops by 1 position. But then D should fall. I think this is correct as is. Yeah, because now everything falls to the ground. So that wasn't the right thing to do. So we have 1, 0, 1 grouped together, 0, 0, 2 grouped together. That seems okay. I don't know what's going on. This seems like a straightforward problem. I'm pretty sure I have a typo somewhere and I'm just not seeing it. Is it always min then max? Maybe not necessarily. I think it is for this input. How about I just print this every time I set one? It should be, it's probably going to be transposed in some weird way. So what is my min min and max max? So it's 2 by 2 by like 10. So we're looking at every slice. So we have ground and then cube or brick 0. Well, that doesn't look right. So we have 0 and 0 here. How do we end up with like an L-shaped brick? That doesn't make sense. How did this happen? If we have 2 zeros in this layer, we should also have 2 zeros in this layer. This does not make sense. So let me format this just like the input. We have x min, comma, y min, comma, z min, comma, tilde, tilde not comma. That's, what the hell is going on? I forgot subscripts there. One zero one one two one. What? This shouldn't make a difference. I think I under allocated my array. So this should be max plus 1 in every dimension. I think that was it. I had out of bounds array indices, but instead of crashing, it just gave me a wrong answer. That was tricky. So did we end up with everything in the right place? I think it might still be wrong. Oh, yeah, I was looking at max. So I was looking at max and being like, G should be at 5, but yeah, G has a min at 5. So A has a min at 1. B and C have mins at 2. D and E have mins at 3. If I can select just that line, there we go. D and E, and then F should have a min at 4, and G should have a min at 5. I think this is right. Before I get to the disintegration, I need another drink. So I will be right back. All right. Hey. I finally made a little progress. So I still haven't solved part 1. I still have to disintegrate. I was worried about how to do this efficiently, so I didn't want to make like an order n squared comparison by comparing every pair of bricks to see if they neighbor. But I think with the data structure that we set up to see when things are falling, we can see if a brick is supporting any other brick. So we only need to look at the top layer of each brick because only the top layer can support another brick. If they're touching at the side, it doesn't count as support. It has to be touching from the top. So at the top layer of a brick, if there's any non-empty space above it, then it's supporting something. And that means if it's supporting another brick, it cannot be disintegrated. So I think I can do part one here. Callie, come on, you've got to go. I'm sorry. She really hates it when I stream. Oh, no, that's not quite right. Because if a brick is supporting another brick, it doesn't necessarily mean that I can't disintegrate it. Because if everything that it's supporting is also supported by some other brick, then it's still safe to disintegrate. How big is this input again? You have 1,300 bricks. So can I just allocate an adjacency matrix? What exactly is the condition that makes it safe to disintegrate? I should be able to get rid of all these ugly braces. Okay, that's still the same thing. So if a brick is the only brick that is supporting another brick, it cannot be disintegrated. So we need like a graph or an adjacency matrix that represents which bricks are supporting other bricks or which bricks are being supported by other bricks. I think it's easier to work with if a brick is supported by another brick. And then we really only need to look for two. Still not really sure how to do this efficiently. Because we can get the is supported by data efficiently with this voxel array. But you can't just decide comparison by looking at 2 bricks. You have to look at like the entire set of bricks. Maybe I should read this and think about it. Okay, yeah, this can be done efficiently. So we're going to have a Boolean array. So this is just initialized to -1, and it's size 2 by the number of bricks. So this is initially going to be all -1s. And then I'm using a colon to represent either index 0 or index 1 from these 2 positions. So if supported by :I equals j, it means that brick I is supported by brick j. And we only need to keep track of 2. Because if there are at least 2 bricks supporting some other brick, then one of those 2 bricks is redundant. At least according to that brick I. There might be some other brick which is only supported by the one that prevents disintegration. But if there are 2 bricks supporting some brick, then that means one of them could be redundant in relation to the one brick that we're considering. Uh, so we might almost be able to figure this out in this loop, because this is the same as the resting condition. So if a brick comes to rest on another brick, that means it's supported by it. And we can fill out this array. But we have this early exit where we set resting and then we break out of this while loop. So as soon as we find one brick, this is exiting. But I want to look for at least 2 bricks. And maybe that means I don't want this to be a while loop. This code is working though. And it really took me a while to figure out this off by 1 error for the array size. So I want to make sure this still runs. And I think I want to save a backup, just in case I do something stupid and can't remember how to get back to a working state. Okay, now I have a backup, and I can start editing this recklessly. So I want to make these for loops again, and not while loops. And then I don't want to increment those. And now I can fill out this is supported by. And I also need to know whether to set index 0 or index 1. So I need to keep track of the number of bricks that it's being supported by. And that's going to initially be 0, and it's just size the number of bricks. I know that's hidden behind the chat, but the comment is there. So if it comes to rest, then actually I want to refactor this too. Resting is true, first of all, and that will make this work correctly still. Get rid of a lot of these brackets because there's just one thing happening in here. Now I also want to set the supported by array. So at the end supported by I is going to get incremented. But before I do that, supported by the first index is going to be n supported by, and then the second index is going to be I. That's going to be whatever is in the voxel space below. So vox x, y, z, and I didn't even need this for part 2. I was thinking of having a Boolean array, and I was like, well, maybe I should future-proof this and make it integers instead so I can keep track of which brick is where, not just if there's a brick there. And it's already coming in handy for part 1 because I need this. So now we should be able to see which bricks are supported by which bricks. So brick A is not supported by anything because it's resting on the ground. So those are all -1s for A, right? Like brick A, it's just resting on the ground. Now, brick B is supported by 0. So 0 means A, 1 means B, 2 means C. That's how you translate my integers to the puzzles A, B, C, D, E, F, G. C is also supported by A. So I have the relation backwards, but this is actually more useful. So B and C are supported by A, and then D and E are supported by B and C. So we have 1s and 2s. So I think this array is correct. And then, yeah, there are no 6s in this array, so brick G isn't supporting any bricks. Now, we can make like 1 or 2 more passes through this, and we can figure out which bricks are safe to disintegrate. So initially, we're going to say that everything is safe to disintegrate. And then if we figure out that a brick is the only brick that's supporting some other brick, we're going to say it's not safe to be disintegrated. So this is initially true for everything, and then we're going to mark the ones that can't be disintegrated. This is size NB for the number of bricks. Now, basically, we're going to look at the rows that are like this. So some non-negative number and then a negative number. So these rows mean that brick A is the only brick, or brick 0 is the only brick supporting some other brick. And this means that brick 5 is the only brick supporting some other brick. And then everything else should be safe to delete. So 0 and 5, that would be A, B, C, D, E, F. F is not safe to disintegrate. Yeah, F cannot be disintegrated. So I think we're going to get this right. So we initialize this to -1. It's supported by. I was thinking it was is supported by. So if this thing is less than 0, then there's a brick that cannot be disintegrated. But it's not brick I. This means brick I is supported by the thing that cannot be disintegrated. So this is supported by 0 equals false. And then we should get a bunch of trues, and the first one should be false, and the next to the last one should be false. Come on. that's not good. Oh. Okay, so this line messed me up because I checked for a -1 here, and then I tried to use this as an array. I tried to use this -1 as an array index. So we're going to call this the supporter. You've got a supporter and you've got a supportee. So the supporter is the one that's doing the supporting. That still doesn't work. I forgot a semicolon. Okay, so we have a bunch of trues, and then the first one is false, and then next to the last one is false. So that's what I expected. And now we just have to count the trues. I think that's the answer that they want. They just want to know how many can be disintegrated. So we're going to make one more pass through this array. And that should be it. 5 for the test input. Got a good feeling about this. It's going to take a second to sort the bricks, and then it's going to print so much. I have to turn that off. It still printed too much, but it only took 5 seconds to run. Oh, come on, man. I was feeling good. Now, how the hell do I debug this? I need like a 3D visualization tool, and like I could do that if I wanted to. So we don't have negative numbers in here. This is going to overflow. This is definitely going to overflow. And I forgot to put in a check for that. So we only care about the first 2. And if you wanted to keep track of more supporter-supportee relationships, you could make this bigger than 2. But to make this as fast as possible, I only really care about 2. So And instead of crashing, this is just like overwriting some other thing in memory, and then it's giving me a wrong answer. But after struggling with that for a long time, just getting the bricks to rest in the right place, I was ready to look for that for the final answer. So, so it should be not 641 this time. And I also want to get rid of some of the prints. I think I want to get rid of most of the prints, because this is a lot of data. Some of these are okay. So it should be not 641. Well, 641, they said that was too high. So this answer is even higher. That's not good. Do I still get the right answer for the test input? Shouldn't really matter if this is inside or outside of this conditional. I already checked that I was sorting these correctly, I think. I should be able to just use an equivalent condition here. So if n is supported by I equals 1, if the supporter is the only thing supporting brick I, then it can't be disintegrated. So this is saying about half of the bricks can be disintegrated. I mean, that feels like it's possible. I was worried about the ground. I was thinking, like, can a brick be supported by the ground and another brick? But no, that's impossible. Oh, I get it. I have duplicates in here. So if you have like a 2x2 brick that's resting on top of another 2x2 brick and they're perfectly aligned, like they're not like off center, like they're aligned center to center, then this is going to list it twice, or actually 4 times in this array. So I want to not do that. And this is complicated because you could have like multiple bricks that are taking up multiple positions. So yeah, I'm not really sure of an efficient way to do this, but I have to check like every. I'm only keeping track of the first 2, so this is going to be fine. And then I want to I do want to have a guard around this. So call it 0 and 1. These are kind of bad variable names, but so be it. Now, if it's not already listed as one of the supporters, then we're going to go ahead and do this. So this is a little bit messy. There's probably a better way to do this. Okay, and this is lower than my original answer. So this could be right. Cool. That took longer than I thought it would. So is this sort of like the inverse of what I just did? I had this array supported by. Now I might need to look at the inverse relationship, which is supports. How many bricks does a given brick support? No, but that's not it, because it could still be supported by other bricks. Wait. No, I think this is easy. So this can disintegrate. Instead of having a Boolean array that I switch from true to false, now I want to have an integer array where I initialize it to 0 and just add 1 inside of here. I think it's just that easy. I could be wrong. Maybe it's a lot harder, but I think this is possibly not much harder than part 1. So let's make a part 2. I was worried I wasn't going to have time for part 2 tonight, or ever. But I think I can do this. It only takes like 4 seconds to run. I can run both parts, even with redundant file reading and sorting an integer array of like 1,300 or 1,400 numbers. So this is part 2. The hardest thing is just what am I going to name this variable now? N fall, the number of bricks that would fall. You could just sum this up in the same loop as this, I think. Yeah, it should work either way. Semicolon. Part 1 and part 2. I'm not even going to bother with the test input. Let's send it. It's too low. Well, that was overly ambitious. Let's rewind and look at the test input. That doesn't seem right. What was the example answer? 7. Oh. Oh. Oh, it's the chain reaction. Yeah, so this is like only the bricks that are directly supported by A. A only directly supports 2 blocks. But then if those 2 blocks also fall, there are other blocks that are higher up that are indirectly supported by A. Okay, I see. I see why this is slightly more complicated, or more than slightly more complicated. So how do I do that? Do I need a whole graph? I think maybe I need a whole graph to represent the supporting relationships. A would cause all 6 other bricks to fall. Yeah. Because like A is taking up, well, it has 2 empty spaces there, but nothing is there. So yeah, if we get rid of A, everything above it falls. I'm not sure how to do this efficiently. I think you have to like walk a tree. You have to form a tree where you say that A supports B, and B supports C, and C supports D. And then you have to think, well, if A is removed from that tree, how many things are unsupported now? You know what? I'm at 39 stars. I've been streaming for 2 hours. My goal was to get 40 stars this year. I think if I can get 40 stars and stop, I'll feel okay. I think I could probably do this, but I don't think I want to do it right now. I'm getting a little tired. So I'll see what tomorrow's like. If tomorrow is easy, I'll do part 1 of tomorrow. And then if I have extra time, I might come back and look at part 2 here. Because it doesn't seem impossible, like day 21, part 2. So yeah, I might come back to it, but I think I'm just going to commit what I have for now and then call it a night. Okay, that's not too verbose. So I want to comment this out because I don't want somebody to pull my code and just assume that part 2 is right because it runs. I spelling disintegrating right? Because it's like integrating, but the opposite of integrating. So it's disintegrating. Yeah, that's right. So I think we have like a lot of prerequisites here. Like we have the supported by array, and that's basically the tree. But we need the whole tree. I don't think we can just cap it at 2 for part 2 because we want to know all of the bricks that are supported by a brick, not just the first 2. Because for part 1, it's fine. We only need to know if there's more than 1 brick supporting a brick. And then if there's only 1, it's not redundant and it's not safe to disintegrate. But for part 2, we need to know the whole tree. So you have to get rid of this cap. And if I just set this cap sufficiently high, I think it should be fine. And then I'll also need to check for overflow to make sure that I'm setting this capacity high enough. So, did I get rid of that? Oh, yeah. So I want to have like else. And then exit. Now that I have this handy exit function, let's check if that works. Might as well do that right now. I'm not going to go all the way with part 2, but I want to put some notes for myself of like what needs to be done. Okay. So I don't know. Can we do like 32? Or will that still overflow? Okay, 32 is big enough. What's the limit? Because yeah, I don't know. Like maybe 16 would work. I don't know what the capacity needs to be. And then this is going to need to be extended because it's not just 2. I have to check anything up to however many bricks have been listed so far. And this is what I don't know how to do efficiently. Like you want to push something to a list, but only if it's not already in that list. You could do this with an adjacency matrix, but the adjacency matrix also wastes a bunch of memory, so that's not. You're just trading space for time, or vice versa. But I mean, if it's only 32, that's not like a huge number. If we have to loop through an array of 32, it shouldn't take forever. It should be okay for this problem. For like a general problem, Maybe you don't want to loop through an entire array to see if something has already been listed. You might want to use like a binary tree or some kind of efficient data structure. I don't even know what the right data structure would be. So you need to set this tree, and then you need to walk that tree to figure out how the chain reactions work. I'm not entirely sure how to do that right now, but I'm not going to try it right now. Does this still run? It was 451, still the right answer for part 1? Yep. Okay. Yeah, I think I'm going to commit this now and then call it a night. I don't need this. I don't really understand why Git is like this. Okay, now it's gone. All right. I think I will stream tomorrow. Tomorrow's a Saturday, so I'll probably stream in the morning. And eventually I'm going to stop doing this because I have to go do Christmas stuff. What was I doing? I want to check. Yeah, this is the commit. Starting to get a little bit tired of Advent code, but we're close to the end, and this day, like I didn't do part 2, but part 1 wasn't that bad. Okay, what I need I need something intrinsic to syntran to not just give me something close to the max 2-byte integer, or 32-bit integer, I mean, but like the exact upper bound, because it's nice to have. But you also have to be careful to not do negative huge, because that could underflow. Because like the integer storage range isn't symmetric. Like the negative min is just the negative max, but plus or minus 1. It's not a symmetric range. Anyway, there's the code from today. I think that's it for tonight, so I will catch you next time.